In this question, two particles are executing SHM in straight line with same amplitude and time period t. Okay, so and at time period t equal to 0, one particle is at displacement x1 equal to plus a and other is at the x2 equal to minus a by 2. They are approaching towards each other. They cross each other at a time. So we can solve this question using two approaches. So let's solve this question using the SHM equation. So if this is the origin or mean position, okay, so first particle is at this location. So x1 is at this location at t equal to 0 and x2 at minus a by 2 at t equal to 0. Now they are approaching towards each other, means direction of first particle is this, direction of second particle is this. So we have to write down the equation for this. So it will be, let's write down the equation for x1. So it will be amplitude into sine omega t plus pi by 2. Okay, so this is a standard equation starting from mean position. x2, this is a into sine omega t minus phi. We have to find out the phi. So at t equal to 0, it is minus a by 2. So from this information we can calculate that value of phi. So at t equal to 0, this expression will become a into sine minus phi. So this is minus a sine phi. So this is sine phi equal to minus 1 by 2, right? Minus sine phi equal to minus 1 by 2. So from this information, we get that phi equal to pi by 6. So this equation becomes a into sine omega t minus pi by 6. Okay. So now we have to calculate a time when both the particles are crossing each other. Means after some time t, this particle will be some here position. Now and second particle will be traveling in this position. Okay. So at this position, they will be crossing each other. So time taken by each particle to reach this point. Okay. So this will be same, and this time period we have to calculate. So that means their position is equal. So that means you have to equate the x1 and x2. Okay. So this is x1 at time t equal to x2 at time t. That means a sine omega t plus pi by 2 equal to a sine omega t minus pi by 6. Okay. So we have to calculate a time when both will be at the same position. So if you look at this, this is 90 plus angle, right? This is 90 plus angle theta, and this is starting from minus pi by 6 plus theta. Okay. So minus pi by 6 means minus 30 degrees. So we should know at what angle this sines will be equal. So see, if you can see in the diagram that this first particle will be reaching the mean position in t by 4 time, right? So your answer should be less than t by 4. Okay. So if your answer is less than t by 4, okay, then there is only one option which is matching. Okay. So in this way we can attempt this question, or we can calculate. So t by 4 time period, that means pi by 2 angle. Okay. So this value of theta should be less than pi by 2. So at 60 degree, okay, so at theta equal to 60 degree, this angle will become 150 and this angle will become plus 30. Okay. So sine 150, that is half plus half, and this is sine 30, this is also plus half, right? So that means their position will be same at theta equal to 150 degree. This total angle equal to 150 degree. That means theta equal to 60 degree. So if omega t equal to pi by 3, then we can calculate the time period as pi by 3 omega, that is pi upon 3 into 2 pi by t. So this will be t by 6. Okay, so using this, solving this, we also arrived at the same answer. Okay, so this is one way to solve. Another easiest approach is, whenever it is possible, use diagrams. Okay, diagram will be helping you solve the question in lesser steps. So let's understand this question from the uniform circular motion point of view. SHM is nothing but projection of UCM on its diameter, right? So let's say this is a diagram. Now if you look at the x1 particle, it is at this location. Okay, and if you look at the x2, it is at this location, right? Now if they are starting from this position at t equal to 0 and t equal to 0, let's say at t equal to t time, they are crossing each other at this position. That means x2 has traveled this much angle, x1 has traveled this much angle. Okay, and because this is UCM, SHM, both the particles are having same omega, right? So if you look at this, now this total angle, we know that this is 90 degree. Okay, this is 90 degree and this is pi by 6, that is 30 degree. So this total angle is pi by 2 plus pi by 6, that is 120 degree. 120 degree means 2 pi by 3. Okay, so this 2 pi by 3 angle is covered by both the objects. Okay, both the particles. Okay, so their relative angular velocity is 2 omega, their relative displacement is 2 pi by 3. So we can calculate time period 2 pi by 3 displacement upon 2 omega angular velocity, that is relative angular velocity. So this is nothing but pi by 3 omega, which is nothing but pi upon 3 into 2 pi by t. So this will be t upon 6. Okay, so in both the ways we have arrived at the same answer. Okay,